I'm at Cyrus now, and today's talk is about how to use Kubernetes to manage a fleet of Kubernetes clusters. I'm not going to talk about any specific solutions, but just the type of problem that I have faced and I still face, and what type of features I would like in any solutions that I use, which is Kubernetes-based to manage like a fleet of Kubernetes clusters. So a little bit about me. My name is Gianluca Mardente, and now I'm Cyrus, and here are a few links, my GitHub and LinkedIn profile. And yeah, I've been working on Kubernetes since 2018. I was at Tagara first, working on Project Calico, then at Cisco, and now at Cyrus, still working on Kubernetes. So if we are all here is because we work on Kubernetes, and either directly or indirectly, I think we end up like managing more than one cluster. When I was at Tagara, creating a cluster was really a big deal. Now creating a cluster, it's pretty common thing. And so we are a small startup, and I already have to deal with 20 clusters, some short-lived, some long-lived. So it's I really needed a solution which which makes my life a little easier. So if we think about Kubernetes, one of the things that I really like about Kubernetes is that we can easily express what we want, and then Kubernetes and the set of controllers that are deployed on the Kubernetes clusters make it happen. If I want a deployment with 3 replicas, I just create like a deployment. I set replicas to 3, and then the deployment controller creates the replica set, and the replica controller creates 3 pods. And if one of those pods goes down, the replica controller is smart enough to detect that and creates another pod. So my intent, the Kubernetes cluster and its controllers keep working toward making sure that my intent, it's always respected. And so what I want, if I use a Kubernetes solution to manage a fleet of Kubernetes clusters, the first thing I want to be able to easily express my intent. And I want a system that keeps reacting and making sure that, what I want is there. I don't want to sit there and making sure that, I want like this cluster to be in this state, I change, then I have to do something manually. I want the solutions like to make it happen for me. Today, there are many solutions to create a Kubernetes cluster, starting from another Kubernetes cluster. We had a nice talk from Giuseppe Arancio just now on Cluster API and Proxmox. So Cluster API is one of the solutions. If you don't know what Cluster API is, it's a set of Kubernetes controllers that you deploy in a Kubernetes cluster, which is the management cluster. And from there, then you can use a Cluster API introduces a set of custom resource definition. One of those custom resource definition, it's called cluster. And so if you create a cluster instance, you can specify this is the Kubernetes version that I want. This is the number of control planes that I want. This is the number of worker nodes that I want. And Cluster API with those infrastructure provider creates the cluster for you. It doesn't matter if you need to create a cluster on AWS, on GCP, or on-prem. There are infrastructure provider for any cloud or on-prem. Cloudy is such another solution. The approach is similar. In a management cluster, you deploy Cloudy, and Cloudy provides another set of custom resource definition where you can define what your cluster should look like. And if you're using either Cloudy or Cluster API, once the cluster is created, if you want to upgrade the cluster, simply there is in the cluster spec, there is a field called version. You change the version and boom, like the cluster gets upgraded for you. There is no work that you need to do. But now, once you create a cluster, you want to deploy application on this cluster, right? At the end, you created the cluster. I don't know. I don't think anybody creates a cluster for fun, but if you create a cluster for fun and it's up there, it's okay. But most of us create a cluster to deploy something that runs on that cluster at the end. And if you're using, again, from the management cluster, you're using a solution that allows you to manage applications and add-ons on those clusters. What you want is to be able to easily express what applications you need you want to have on those clusters. And sometimes those applications are independent. So you can simply say, I want application A, B, and C. They are independent. They can be deployed like in parallel, and that's all good. But sometimes things are a little bit more complex. Application B might depend on application A, which means that you cannot deploy application B unless application A is already deployed on a cluster. An example will be if I'm deploying a set of Caverno admission policies. I cannot deploy those Caverno admission policies unless I've already deployed Caverno and the Caverno custom resource definition. So the Caverno admission policies will be the application B and the resources B that I want to deploy, and the application A is going to be the Caverno Helm chart and the custom resource definition. Other times things are even a little bit more complex because it's not enough B depends on A, but A needs to be in a very precise state before B can be deployed. So things are, you need to be able to define a state machine and look at the state of the resources to understand when to move from one state to the next state. And finally, things can get even like a bit more complex if your application depends from cloud resources, because now those resources are outside of your cluster. Still, you want something that allows you to create those resources outside the cluster and move so be able to create a state machine even in that case. So these are like just few examples just to go on what I was discussing. I have a management cluster and I have two managed clusters. One simple thing that I want to be able to say, it's I have two applications and I want to deploy Prometheus first. And once Prometheus is deployed, I want to deploy Grafana. I mean, there is really no order in this case, but this is just, I want to be able, if I'm using a Kubernetes approach to deploy application on a Kubernetes cluster, I want to be able to easily define a state machine. First A and then B. This is it's a more complex case where I want to deploy a Postgres database and then I want to make sure that the Postgres it's ready. And only when the Postgres is ready, deploy a job that creates a table in the database. And only when the job, then wait for the job to complete. And only when the job is completed, deploy another application. And only when this application is healthy, finally deploy a job that through this application creates an entry in the database. So again, the goal of this slide is to express what we want, so that we want to be able to define a state, and the state is deploy this one, and we want to be able to understand when to move to the next state. Moving to the next state, we need to watch at the state of Kubernetes resources in the managed cluster, and only at that point move. So that's what we have to wait, and all the time we have to wait for job to complete. In this case, job to be completed. We have to look at the job resource and make sure that the status is set to completed. So that's what we want. And if you're thinking of using Cloud Native PG for this one, yes, you should. I'll use Cloud Native PG. I love Cloud Native PG. The goal of this slide is not how to create a Postgres database. If you have to create a Postgres database on Kubernetes, use Cloud Native PG. The goal here is that if you're using a Kubernetes solution to manage applications, you should be able to define a state, and the state should be able to look at the resources in the Kubernetes cluster before moving to the next state. So sometimes now, if you're managing N clusters, one thing that you want to do is reduce the amount of configuration. For instance, if I'm deploying the same application in different clusters, I'm deploying an application on a testing cluster and I'm deploying the same application in production cluster. Clearly, on the testing cluster, I want, for instance, the replica to be set to 1 because I only care about testing the functionality of my application. But when I deploy in production, I want the replica to be set to 3 because I want high availability for my application. So if you know upfront, if you know this information up front, that in this cluster replica should be set to 1 and in production replica should be set to 3, you can use a tool like Customize, and that it's good enough. But sometimes you do not have this information up front, and so what you want is to be able to express the application, the resources that you want to deploy as templates, and be able to instantiate those templates at runtime, fetching other resources from either the management cluster or the managed cluster. So here I have an example. So what I want to do here, I want to create a Kubernetes cluster, and then I want to create a storage bucket. And finally, I want to deploy a pod in the managed cluster. And this pod should be able to collect some logs from the managed cluster where it's running and update those logs to the bucket. So using Kubernetes, I can create with cluster API, I can create a cluster, and that's perfect. And now I can deploy Crossplane, for instance, in my management cluster, and I can create a Crossplane bucket. So when I create the Crossplane bucket in the management cluster, what Crossplane is going to do is going to create the bucket in this case, like I'm using Google, so it's going to create like a Google bucket. And when that operation is done, it's going to update the status of the Crossplane bucket resource with the bucket URL. So I did not have like this information. So I have this information just at runtime. I did not have like this information up front because Crossplane is creating it. So I do not have that information like before. So if I can express the pod as a template, and I can now fetch the Crossplane bucket resource, take the bucket URL, instantiate the template. Now I have a pod that I can deploy in the managed cluster. This pod can do its job of collecting the logs and can upload the logs to the bucket that has been just created. So this is powerful because, again, you do not have to file a ticket for somebody to create a bucket, give you the bucket URL, you go back to your desk and now deploy the pod to the managed cluster with the right bucket information. And you can replicate this one because maybe you need like to, this is a workflow that you have to do anytime you create, you're testing your application. Maybe the application that you're testing is actually the pod that you're deploying. And if you have a solution like this one, you can replicate this one like 10 times. And anytime, pretty much, the only things you're testing is actually the functionality of your pod. You're not testing like anything else. This is yet another example. Sometimes you want, you need other applications to be deployed in response to events that happen in the cluster. And so I can define, I want solutions where I'm able to easily define what an event is. For instance, I can say that for me, an event, it's the creation of a service. A service of type load balancer for me is an event. And so when I see that a service is created, I want a system that is able to detect, report that this event has been detected, and do in response what I want to be done. So to create like a network policy that exposes like this service. So maybe this service now is reachable from other applications which are running in the same cluster or are running like in different clusters. In this case, pretty much I could have even created in response a selectorless service in the other managed cluster where I use the service load balancer API and I make pretty much this service reachable from pods which are running in the other Kubernetes cluster. This is with respect to application, but now when it comes like to clusters, we have two types of clusters that we deal with. So we have short-lived cluster because again, creating a cluster today is very easy. And so maybe your goal is you're working on your application and your goal is anytime you make a change, you want to create an environment where you deploy your application, you test your application and delete the cluster. So when you're dealing with short-lived cluster, the main problem probably you're dealing with is consistency. You want a way to recreate your cluster in a consistent way. So same Kubernetes version, same number of worker nodes, same number of control plane nodes, same number of applications that are deployed on this cluster. But sometimes you're dealing with long-lived clusters. And when you deal with long-lived cluster, now the set of problems that you are different. Because very likely now you have to upgrade the cluster, you have to upgrade the applications that are running on this cluster. And if it's a long-lived cluster, very likely you have different type of admins that are involved. Because maybe you have a platform admin, and the platform admin is the one that decides when it's time to upgrade the Kubernetes version. And maybe you have different type, you have different applications, and you have so different admins that are managing those applications. Maybe you have like an admin for the CNI and the network policies. You have another admin for other applications that you deployed like in-house. So, and sometimes those applications really depend on the Kubernetes version, meaning that if you're about to upgrade a Kubernetes cluster, you may need to upgrade your application. Or if you're downgrading the cluster, you need to downgrade the application. Now you have two choices here. Either you say like, again, you go with a ticket-based system where anytime like the platform admin decides that the cluster needs to be upgraded, you files a ticket notifying all the other admins managing the application. I'm about to upgrade the cluster. If there is an action that you have to take the action. Of course, pretty much like if you take this approach, sooner or later, someone forgets to take action to respond like to the ticket, you upgrade the cluster, and one of the applications stops working. The other approach that you can take is that you can have solutions that allow those admins to create contracts. For instance, like the admin managing the application can say, if the Kubernetes cluster is running this version, this is the version of the applications that I want. And if the Kubernetes cluster is running this other version, this is the version of my application that I want. Now, if you have a system like that, let's say that we have two managed clusters in this case, which are running one Kubernetes version which is less than 130. So as an application admin, I can say, well, if the cluster is running a Kubernetes version which is less than 130, this is the version of my application of Gatekeeper that I want to be deployed. And now you have a system that can classify the cluster based on the Kubernetes version that they're running. So in this case, both clusters are a match for this rule. So what happens is that Gatekeeper gets deployed on those clusters with this very specific version. But now if the platform admin decides that one of the cluster needs to be upgraded, what if I add another rule that says, if your cluster, if the Kubernetes cluster is running a version which is strictly higher than 130, then the version of Gatekeeper that I want to use is 310, is not 39 anymore. So now what happens that if the platform admin upgrades the cluster, the solutions that you're using detect that this cluster is now a match for this rule, is not a match for the other rule, and automatically upgrades the application. So if you have a solution like this, your admins, they do not need to talk to each other. As a application admin, I simply need to create a set of rules that dictates what is the version of my application or the configuration of my application based on the state of the Kubernetes cluster. In this case, I'm using the Kubernetes version, but it could be like any runtime state that can be detected and that can be used to classify a cluster. And of course, like if you take this approach, I think it's at least if I were one of those admins, I would be happy because I would not have to sit like in a room discussing with all the times like, oh, I'm upgrading the cluster, what I have to do, what you have to do, and so syncing and finding a timing we can do those operations. Now, if you're dealing with, if you're managing a lot of clusters, maybe also you're managing those clusters on behalf of somebody else. So you have multiple tenants that are all coming to the management cluster, but each one of them is managing a subset of the cluster or maybe a subset of the application on a subset of the clusters. So in this case, you may have the platform admin, which has a vision of all the clusters. And this platform admin may create like clusters for different tenants. So I may create like 3 clusters for tenant Pepsi. I may create like 5 clusters for tenant Coke. And then I can hand over like the management of those clusters to them. Yet I can allow each of those admin using the proper Kubernetes RBAC to come to the management cluster and manage from a single place all the cluster that they own. So for instance, I can say that the tenant 1 admin has a namespace which is reserved for him. And in this namespace are where all the managed cluster that belongs to tenant 1 are represented. And tenant 1 can do at this point, can decide the configuration that has to go to his cluster. So he has no vision using Kubernetes RBAC. He has no vision of the other clusters that belong to the other tenant because his visibility is limited to his namespace. He can dictate what the configuration of his own cluster should be without affecting the other cluster, yet he has a single place where he can go and control all of this configuration. So yeah, hopefully I think I went like really fast because I was scared of not having enough time, but those are all the problems that at least I've encountered in my career working on Kubernetes and managing multiple clusters. I'm lazy and I tend not to recall what I have to do unless I do it immediately. So having a solutions that allow me like to put a policy in place at the time where I know what needs to happen, and then having a solution that when the system moves, takes the right set of rules and does the right job is something that I'm looking forward to. I don't. Again, there are many solutions that have all of this feature or part of this feature, or where you combine a solution with another and achieve what you need. So I'm not gonna go in the specific of which solution you should pick, but those are the kind of problems that I faced. And having a solution that fixed those problems honestly made my life much easier. Today, like, again, as I mentioned before, we have close to 20 cluster, and I'm not stressed. I lost my hair like many years back, not because of managing clusters. So I'm happy with this. Yeah. So thank you.